Like I said, our goal today is we're taking quantitative distributions and we're going to graph them with a dot plot, a histogram, stem plot, box plot. I'm going to try to go fast because you hopefully learned a lot of this like in middle school, 9th or maybe 10th grade. You will need your, like I said, on the AP exam, the first question you will have to graph one of these. Dot plot, histogram, box plot, or stem plot. So if you want to write down the goal real quick, and then we're going to go down to example 6. Are we fans of writing on the goal or not? Because I can just we can go. If you don't want to write it down, I don't care. But then I'll just say, hey, here's our goal. Here's what we need to get done. And then let's just get going on the problem. Okay, so here's the number of turnovers for the 2009 Oakland Raiders football team during their 16 regular season NFL games. And we have all of the data. Create a dot plot that displays the distribution, then describe the distribution. So we're going to be doing all the description piece on Monday and Tuesday of next week. Dot plot you are going to use probably the most, and here's the reason. We're going to learn 12 different tests of significance. What do I mean by that? We've already talked about what significant data means. It means the observed response is so large it couldn't have happened by chance. Well, we're going to have a test for that, so we can say for sure yes or no, it is significant, or no, it's not. You will have to use a dot plot oftentimes in the significance test. In fact, I think you have to use it in 6 of the 12. You can use other ones. You could do a box plot or a histogram, but the reason I like the dot plot is it's very quick, okay? With the dot plots, we're just going to take our, like a number line. We're going to look at our minimum, okay? Our minimum up here is 0. Our maximum is 4. So on my number line down here, I'm just going to go by 1. So you always want to look at your min and your max when deciding your scale. So I'm just going to put 0, 1, 2, 3, 4. You want to label that number line, okay? So that number line will be the number of turnovers for the 2009 Oakland Raiders football team. And then I'm just going to start and I'm going to read left to right. Now, I personally don't like dots. I think they're too little, so I like to do X's. So I start with my first observation, which is 3, and I'm going to make an X. I have 0. I'm going to make that X the same size, approximately, obviously. Now I have 3 3s, so I'm going to do 1 on top of the other. I have 2. I have a 4. I have a 1. Now, I'm right here. I stopped there. The next observation, this is my second 2. One thing I'm going to be a little bit picky on is making sure all of your X's are the same size. And you can notice that all of my first observations are in a nice row here. So then all of my second observations need to be in a nice row. So this is the second 2 that I have. And it goes right there. 3, 1. I have another second observation. Again, in the same row with those other second observations. I'm at a 0, 1, 2, 3, 2. That's it. Now, am I going to be taking a ruler and making sure they're all on the same row? No, but just do your best. Have them all the same size approximately, same rows for all those observations. And that's a dot plot. It goes very quick. Questions at all? All right, let's move on. Stem plot. I don't have a cutout for a stem plot, so if you could just take a second and write this down. Grades on a recent test are as follows. 55, 56, 72, 82, 84, 89, 92, 92, 94, 95, 96, and 102. A stem plot is a fancier way of saying stem and leaf plot. Do you remember the stem and leaf plot from middle school, 9th grade maybe? Some of you never had it? That's okay. I'll refer to it as a stem and leaf as we're teaching, but it technically is a stem plot. I passed back your homework while you guys were cutting things out. Those of you who didn't get anything back, I don't have homework for you. That is 34 points. Keep in mind, you are grading yourself. When you get your test score back, really reflected, you do enough practice. This unit, I am not going to be picky about homework at all. It's very, I'll only be picky about 1.3C. Okay, that's the description piece. That's the finding the mean and the median, finding your IQR, finding your standard deviation. Make sure you check your updates from me so you know exactly what's expected. Okay. All right, so Stemplots, step 1. It is important, actually, I talked about the min and the max. It is important to maybe write it down for some of you. So my minimum is 55. I put it in order for you already. My maximum is 102. Now, the reason I write it down is because we're going to determine our stems for step 2. And in order to determine our stems, we need to cover the last digit of your min and your max. And these are our stems. So when I cover that last digit, I'll use a highlighter to do it so you can still see the numbers. I'm left with 5 and 10. That means my stems go from 5 all the way to 10. Okay? My stems go from 5 all the way to 10. So my actual stems for this problem Any questions so far? To make my stem plot, I'm making essentially a T-chart. You need 7 lines for that T-chart. On the left-hand side is where your stems are going to go. I start with 5, 6, 7, 8, 9, and 10. After I have my stems, I then have my leaves. Your leaves are your last digit. And it has to go in increasing order. So I put it in order for you to make it easier. If you're making a stem plot, you may want to put all the data in order first, just to make it easier on yourself. You don't have to, but just remember those leaves do have to go in increasing order. So for our first number, 55, if you cover up that last digit, you can see that the stem for 55 is 5. So 55 represents a 5 as a stem and then a 5 as a leaf. 56 then, a 5 for a stem, a 6 for a leaf. Now you notice, are there questions right there? Yes?
Should you like put a comma or something?
No, yeah, that's a really good question. Typically we don't put commas. I've never seen one. I don't know that you would be docked wrong on an AP test for having a comma, but it's just practice that you never have a comma.
Okay.
Good
Just
question.
leave enough space. So.
Yeah, just leave like a decent enough space. Also notice 6, our stem 6. We don't have any data that starts with a 6. We still need to have that 6 on the stems. So whatever, even if it's missing some leaves, that's okay because that's going to be part of our description. So we're going to have nothing there for the 6, and then we go to the 7, and we have 72. And try to have nice columns again. So instead of rows, I'm going to have columns. 55 is my first observation. 72 is my first observation for the 70s, right? So nice columns. I have 72. I have 82. I have 84. That's my second observation in the 80s. It's in the same column as 56, which is my second observation in the 50s. 89. 92. We do put repeats. 92. 94. 95. And 96. And then finally 102. Bless you. Why do we use a Stempplot? A Stempplot is nice. I'm going to talk about that with the description. But a Stempplot is especially nice for a small sample size. So you might want to write that in the margin. You only use this with a small sample size. If I had 100 numbers, I wouldn't want to do a Stempplot. That's just way too many numbers. But with a small sample size, it doesn't take very long to make a Stempplot. And the benefit of that is I can actually see the data compared to a histogram, which I'll show you here in a second. Questions? So we're going to finish here pretty early compared to my last class. My last class is a little bit more chatty than you guys. So we'll have a choice to make. So just kind of keep in your mind, if you want to cruise through, we won't have as much to do Monday, or if it's Friday, you want to just take a little bit of break. We're just going to do the histogram. After that, we'll be done, or we can keep cruising if you want. Okay? So just take a little mental note as we're going. Any questions on Stemplots? All right. Like I said, it's not the most exciting, but you do need to know how to do all of them. The next one is example 8, which is histograms. I'll read it while you're gluing it in. The following table presents the average points scored per game for 30 NBA teams in the 2009-2010 regular season. Create a frequency histogram and a relative histogram of the data. Describe the distribution. I think you need at least probably a quarter of a page if you write small. Maybe a third of a page. Alright, I want to be clear with you, when you do a histogram, all I'm going to be grading is the histogram. But there's some strategy that leads up to it that some of you can do in your head, not all of you. Please write down all of the steps for here, and again, just know that I'm only going to be grading all of the plots. So even the Stempplot, I'm not going to look that you wrote down the min and the max, covering it up, all that. This one has probably the most work involved in it, though, or side work, if you want to call it that. The first thing you want to notice is there's two histograms that it's asking for, a frequency one and a relative one. What did we learn yesterday about the word relative?
Percent.
Yeah, percentages. So just make a little note that that means percent. Let's start with the frequency histogram, and then that will lead us to the relative histogram. So our step one is the same as it's been on all of them. You want to look at your min and your max. So I'm going to write it down here. So my minimum, I believe, if I look, I think I had a 92 in there. 92.4, I see. Does anyone see anything lower than 92.4? Okay, so 92.4. And my maximum, I believe, was in the 110. 110.2? And now what we need to do is we need to describe, or we need to decide our scale just like we did for a dot plot. Okay? Now 92 to 110, I'm going to have to plot all these numbers. What seems like a reasonable scale?
5.
90 to what? 9. We could start at 90. If we start at 90, what would we want to start? What would our scale want to be?
Could you do 91 to 111?
You could do 91 to 111. Now, I don't like that only for the fact 91 is is an odd number. I like to start on an even number. It's just a weird thing I have. You can do that. There's lots of different options for you here. I'm going to say let's scale this by 5s. I think scaling by 5s, 10s, 20s, or 50s are always a good thing. 2s, we did 2s in the last class. And it got to be just a little bit too much, okay? Now, I do want to say, okay, I like multiples of 5s, personally. If you're struggling with what the scale should be, a nice kind of guide for you would be to take the range. Remember what the range is back in like middle school? What is the range? Yeah, the max minus the min, and divide it by 6. When you do that, I believe you get 2 point something. Okay? So we could round down to 2 or we could round up to 5. So I would keep it as like an even number or a multiple of 5. So I think I decided, or we decided, let's go by 5s. Question?
Why do you divide by 6?
6 is going to give you approximately 6 bars, 5 to 6 bars. Okay. You want a decent amount of bars so you can see the shape. If you just have 2 bars, you don't really know what's going on with the data. Okay? Because ultimately, we're going to have our data, we plot it, and we're going to draw conclusions about it. That's what we'll be getting to on Monday and Tuesday of next week. Questions? Okay, so our next step is we're going to make a frequency table. And if we're going to go by 5s, we're going to start with a multiple of 5.
So 90.
We're going to start with 90, yeah. And now, I know we don't have books this year, but all of the books that you will encounter in statistics, at least that I have seen, they call this area here either your bin or your class. It's essentially what your bars will be made of. And then over here on the right is going to be your frequency of how often it occurs. So I'm going to start at 90. Now watch. This first bar is going to go from 90. It can be 90. Everything in this bar, so look at my finger up here, everything in this bar can be from 90 to up to 95. It cannot include 95. And why is that? I'm going by 5s. 90, 91, 92, 93, 94 is 5 numbers. So I don't include 95. I'm going to make my next bin. I'm going to go from 95. Everything in this bin can include everything from 95 up to 100. We're going to keep going. 100. 105. 200. Do I need any more bins?
Yeah. No.
Okay, we should be good. Okay, so now what we need to do for each bin is we need to count the data. How many numbers are between 90 up to 95? So you cannot include 95. So go through that now and start counting, okay? I would suggest with data like this that's out of order especially, cross it off as you're using it. When someone gets it, can someone tell me what it is? Because we did 2s in the last class. I hear 2. 2? Okay, thank you for the confirmation. So there's 2 numbers that are between 90 and up to 95. 95 to 100. $10, okay. 100 to 105. Remember, you can't include 105. $15, I hear. 16. 15. Okay. 105 to 110. Again, don't include that 110. 2. Anyone else confirm?
Yeah.
Okay. And then 1 in the last one. Okay. Look at the frequency table. Do you guys have any questions about that? All right, so let's actually do the frequency histogram now. Was there a question? No? Okay. I know it, again, like I said, it doesn't require that much higher order thinking. We just have to get it done. So we're going to draw our X and our Y. And on the Y-axis will always be our frequency. And on our X-axis will be our bins. And you need to label what those bins represent. So what do these bins represent?
Points.
Yeah, the points scored. So we can just put the PT as G, I believe is how they said it. And I'm going to change my width now. So we're going to start at 90. So on the X-axis is when we can make the little mark. I talked about that yesterday. And I'm going to go by 5, so 90. And this is small. Oh. Oops. Questions on that X-axis? And now if we look at our frequency, our lowest is 1, our highest is 15. We have a 2, we have a 10. What would make sense to go by for a scale? I would do 5s personally, yeah. 5. Okay, for those of you who haven't made a histogram before, it's very similar to a bar graph. The difference is a bar graph is for categorical data, what we did yesterday quickly. A histogram is for quantitative data. And with a histogram, the bars have to touch. So watch how I do this if you don't remember how to do this from way back when. From 90 to 95, I start at the 90. Okay, so watch my pen. I have 2 between 90 and 95, so I'm going to go up to where I think approximately 2 is, over and down to the 95. From 95 to 100, I have 10 observations. So I start at 95. Watch up here if you haven't done it for a while. 95, I have 10 observations. I go up to the 10, over, and down to the 100. From 100 to 105, I have 15 observations. So I start at the 100, I go up to 15, over, and down to 105. From 105 to 110, I have 2 observations. And then I have 1 observation. And my board is a little off, so that's why it looks that way. Do you guys have any questions there? We will have to describe it. I'll teach you how to describe it on Monday. Let's just close with what a relative frequency histogram is, but I'll give you a second to get caught up if you need that. Questions? Okay, so for a relative frequency, or for a relative histogram, what you would need to do is you'd have to find the percentages here. We know that there should be 30 observations total in this frequency column. How do I know that? I can add it all up, or they told us in the beginning of the problem that it was 30. And then I need to figure out the percentage. So I'm going to just take 2 divided by 30, 10 divided by 30, 15 divided by 30, 2 divided by 30, and 1 divided by 30. And I'll get my percentages. So when I graph it, over here, I'm still going to go from 90 to 95, or 90 to 115, 90, 95, 100. And we're not going to do it, we're just going to set it up. Now, what's going to be on my y-axis, though?
Percent.
Yeah, the percentages. And that's all that changes. Are there questions there on what a relative histogram is?